This is bellwork for Tuesday, January 23rd. On number 1, it's asking us to simplify 4p to the 7th over 7s squared, and the whole thing is to the second power. So we're going to split this and do them separate. So first let's do 4p to the 7th to the second power. That's going to be 4 to the second power, which is 16. 4 times 4, and then p to the 7 to the second power is 7 times 2. We'll get p to the 14th. And then we do the same thing for the denominator. We're going to do 7s squared to the second. And first we do 7 to the second, which is 7 times 7, which is 49. And then s squared, or s to the second is s to the 4th, and then we end up with 16 p to the 14th over 49 s to the 4th. On number 2, it's asking us to write the equation for the line given. So we have 2 points. The first one we have is x is -4 and y is 5. It's just written in function notation. And the second point we have x is 2 and y is 2. So first we'll figure out what is the slope, and that's just going to be the change in y over the change in x. So we'll have x1, y1, x2, y2, and we'll do y2 minus y1 over x2 minus x1. That's going to be a -3 over 6, which is the same as -1/2. Okay, so our slope is -1/2. We're going to take that and put it into the slope-intercept form using one of these 2 points for our x and y values. So let's use the first one. We'll get 5 for y equals m, which is -1/2, times x, which is -4, and plus b. So we're trying to figure out what is the b value. And we will get 5 equals +2 plus b. Subtract 2 from both sides, and we get b is equal to 3. So m is equal to -1/2, and b is 3. Then we can put it into our slope-intercept form. We'll get y equals -1/2 x plus 3. On number 3, it's asking, is the function linear, quadratic, or exponential? So for this one, I have something interesting happening. So look at the y's. Yeah, we have 2 of the same values for the y here, and then 2 here. Then if I had another y value, it would also be the same. So when that happens, that is what's called a quadratic function. On number 4, it's asking, are the lines parallel, perpendicular, or neither? So we need to find the slopes for each one. So let's do the first one. We have 2y plus 3x equals 5. I want to get the y by itself, so I'm going to subtract 3x from both sides. And I'll get 2y equals -3x plus 5. Then divide by 2. And we'll get y equals -3/2 x plus 5. So my first slope is -3/2. Then do the same thing for the second one. We'll get 3y plus 3x equals 5. I'm going to subtract 3x from both sides. I'll get 3y equals -3x plus 5, and divide by 3. So we get y equals negative x plus 5/3. So the slope for this one is -1. Okay, so I want to compare these slopes. Are they the same? No. That means that they are not parallel. Are they negative reciprocals of each other? No. If I do a negative reciprocal of -3/2, it's going to be positive 2/3. So it is not negative reciprocal, so it's not perpendicular. That means that this one is neither. That's neither. Okay, number 5, it's asking which panda is growing faster. So we have two different representations of the panda growth. The first one we have a table, second one we have a graph. What we need to do is look for rate of change. So it's asking is something changing faster than the other, we're looking for the rate of change. On the first one on the table, we're going from week 0 to week 1, it changed by +4. From week 1 to week 2, it's +4. And then from week 2 to week 3, it's +4. So Panda 1, which is Moki, is changing by +4 each week. So +4 each week. Okay, and then we'll look at the table for Kappa. It's kind of the same idea. At week 0, Kappa was at 2 pounds. On week 1, Kappa was at 5 pounds. So that is a change of +3. This is Kappa. And then from week 1 to week 2, they went from 5 to 8, which is +3. And then from week 2 to 3, also +3, went from 8 to 11. So it is doing +3 each week. So the one that's changing faster, or growing faster, is Moki.